Okay. Yeah. Right. So again, good afternoon, everyone. So today, we're gonna look at the an example of module exam. This is from 2 years ago for 2016 class. So anyway, so let's have a look and let me know if you have any questions to solve this problem. So this is a typical, yeah. So there would be a problem about binary mixture, of course. You can see, and then you can maybe check the vapor phase or liquid phase, and then you take a look at the phase. And there's some properties. We need these properties later on for heat balance. And if you look at here, there is a for number one, it's actually for part A. Is actually there is like the sub questions. Yeah, the sub question of the problems. Yeah, for example, the first one, determine the feed flow rate or the bottom flow rate and so on. And then this is really like step by step. So basically for the so we will have exam next week, and for the exam next week, I would say we will maybe make this into several batch of questions and problems. Yeah, so we really want to minimize plagiarism. Yeah, we really want to minimize plagiarism, of course. Then so maybe only number one, for example, and then you submit it, and then we will give you time to for example, to give number 2A, B, C, for example, and then when you finish, take a picture and then submit it again. So I think the idea would be we will make it like several numbers, yeah, because this is really a sequential. So that means you can't do the bottom number if you haven't finished the first one or the previous one. Yeah? So basically like this one. So this is the compulsory exam or the assessment wajib. Yeah. So that means you need to pass this, otherwise up to yeah you need to pass this, otherwise you need to have remedial, because this is the basic, or this is the compulsory competence that you will have in the exam, right? And I wouldn't say this is a it would be looks like this every, but this is a type. Yeah, so this is a type, but the all the basic things that we have discussed last 2 weeks, of course, it may be in here. Okay, and we will give you the graph one day before. So hopefully you can print it, because I know it is really convenient for you to print it and then do it with your hand, yeah, with your simple ruler and pencil and maybe coloring pens, and this just maybe it's just easier for us, yeah. It is for me, it is for you as well. So I will give the graph one day before. This is an example of XY diagram, and there's another one is a TXY diagram. I think we haven't really have the exercise about this TXY diagram, isn't it? So we'll have a look. If we haven't finished it today, we can continue tomorrow before we just go forward with the multi-component distillation for the next course. And after that, and there's also the second number. The second problem is about non-compulsory assessment, but I think it's better is just you try to answer that one. This is part B, which is student outcome E in ABET. In ABET, it means about problem solving. So the problem, we need to be able to construct a problem and also know how to solve the problems. For example, in this case, after we calculate all the equilibrium stages and also the heat balance and everything's finished, in the part B here, the column fractionator must produce a side product. Yeah? So there would be a side product as a side stream. So looks like there is a side stream there with some sort of composition, and then we need to calculate the new theoretical stages, for example, and then yeah. So then, and also some opinion regarding the column fractionator. Yeah, all right. Okay, so I can't draw in PDF, so I have copied in. I just
Ma'am.
Yeah.
Sorry to interrupt, but our friend Fauzan has not been accepted to the Zoom meeting, ma'am.
Okay.
And I'm sorry, ma'am,
Yeah.
but the absent in 6 is not opened yet.
Oh, okay.
Okay.
Which? Wait. Is it? I thought I have I've written. Okay. All right. Okay, I've done this one. Okay, any other questions or comments? Nope.
Mom, I want to ask,
Yeah.
for the exam, are we going to get an extra time for the uploading the file?
Yeah, you will. How many minutes do you need? 3 minutes, is that okay? To take a picture and then make it into PDF and then submit it to Google Classroom.
Oh, can we submit it as like GPG?
No, you need to do it by using PDF. So that's why I'm asking. How much does it need to convert the PDF using, I don't know, Cam Scanner or something like that?
Maybe 5 to no, I don't ask us. I want to ask the others too.
Yeah, maybe 5 minutes. Yeah, I think so. For example, this case, both of the problem A and problem B is both of them is 100 minutes. Yeah, so that would be, yeah, I think should be the additional minute would be, the maximum is 20 minutes for all of the problems. Yeah, we'll see. Okay, all right. That's why it is better to do exercise, and we're going to do exercise as well, and we're going to continue tomorrow. And as usual, of course, I'm going to put in the assignment into the MS team. Yeah, just any and so yeah, when you finish your work here, just upload it into the assignment. So that's the way I can yeah, I can see your work, I can see your progress, and yeah, it would be good for our teaching as well. Okay, all right. Are you ready? Are you ready with all your papers, or this one here, right? Okay. Okay, I would like I would like a discussion. Yeah, I would like a discussion. So I'm not gonna answer, but some of you should answer the questions. Okay. So the first one, when you read the problem, of course you have to check about the the data in that one. So what are the data that you can find? Can you tell me?
The XD, XB, ma'am.
Okay, XD and XB, yeah. So first, we have the data. Oops. XD and XP. I was curious. Just wait for me a second. Paint brush. Okay, let me. Looks fine, yeah. When I write using Paint, but I don't know. Just difficult to write this one. But anyway, okay. So XB. Where is XB?
90%, ma'am.
Which one is 90% more?
Of A.
This is XD, yeah, distillate, okay?
Yeah,
So this is distillate. Or what I can do, I can maybe just put this one. And copy that into the Paint. Yeah. Okay, anyway. Oh, no, sorry. It doesn't look like this one. Okay, this one can be, which one? This is 90% A, so this is XD. What else? And also the bottom product. Anyone else?
From the question, ma'am, we can get F.
From the question, we can get?
F, flow rate of feed.
Okay, do we have the flow rate of feed?
I meant at part A, the question number 1.
Okay, yeah, this one, yeah. Okay, we can get the feed. What else?
The composition of the feed.
The feed composition, where's the feed composition? This one, yeah? So that would be ZF, yeah. ZF. 0.5. What else? Any other? Wanna try? How about the phase?
Yes, also the phase of the
Yeah. So you can this one. This is the feed phase. Yeah. So you can, there's a 50% liquid and 50% vapor. So what is the Q? Q is the fraction of liquid. Yeah, so it would be about 0.5. Yeah. I don't know why it's just how if I just make a copy of this. Wait. How if I make a copy of this and put it into PowerPoint? Hopefully that's work. Sorry for that. Okay, just continue. What else while I'm doing this one? Okay. Hopefully it will be good. Okay, so let's try writing here. Hopefully this is gonna be better. So we have this one, yeah, 50% mole of liquid. Oh, this is better. This is ZF 0.5, and then also the phases, right? So this become the liquid fraction is become 0.5 because it's 50% liquid. What else? Also, we have the distillate, which is XD 0.9, and the bottom product also 90% B. So that means XB would be equal to 0.9. No, 0.1. Yeah. Okay, what else? Do we have more data?
Maybe the physical properties, ma'am.
Yeah, this is the physical properties. We're gonna need it later for heat balance, yeah? Okay, now the next one is, let's see question number A. If the feed rate is entered with the fractionation with 100 kilomole per joule, please get the find the distillate, yeah. This one. Okay, so if the feed flow rate enter at this one there, calculate the bottom product flow rate. Now, how you gonna solve this one? Any idea? So I would start with maybe start sketching. We also need to check the condenser and reboiler. Yeah, how we check the condenser and reboiler from the problem. How we gonna check the is it partial condenser or total condenser? How we gonna check it?
For the top product, it is collected as liquid.
Right, good. So yeah, the top product is collected as a saturated liquid, right? So because the product is saturated liquid, so it implies that Is it a total condenser or partial condenser?
Partial.
Total, ma'am.
Total, yeah. So again, if you there is in the book there is a three type, but I'm just going to show you the two type. The first one for a partial condenser, so they quench a little bit, make a flash calculation of the vapor there into for the condition there. So it would become two phase, yeah, liquid and the vapor. And the vapor is taken out as the distillate. Yeah, so in the partial condenser, you will have saturated vapor as the product. So in the problem, if the product is collected as saturated vapor, then you have to use partial condenser. In this problem here, the top product is collected as saturated liquid. So the schematic would be looks like all of the vapor there is actually cooled down, yeah, as a liquid. And from this one there would be like a reflux drum. In the reflux drum, there would be valve that control the ones going back into the fractionation column. For example, this is XD, and also this is also XD, yeah. So that's why we call it XD, because it's in the liquid fraction, and this one in the vapor fraction. Okay, good. So this is a total condenser, right? So okay, so I'm gonna write it as a total condenser there, and then we have distillate, and at the bottom here, do we have any information about reboiler there? No, yeah. The energy required for fractionation is generated from a boiler located at the bottom of the column. We don't have any information about reboiler, so if there is no other information here, so we will just assume the most likely boiler is partial reboiler. Yeah. Otherwise, if we call it a total reboiler, or we heat it up the mixture with steam, for example, yeah, it's based on that one. So this one is a partial reboiler. Okay, so I'm gonna write this as a partial reboiler. In partial reboiler, all the liquid there is heated up. So some of the vapor going back into the column, while the liquid is withdrawn as the bottom. Okay. Now, so this is B. The flow rate is B. With this one is ZF, and this is the composition at XF. Okay. So now we have to check the mass balance. Yeah, the mass balance. We can check the mass balance. The first one is for total, and also for the component mass balance. Okay, for the total, can you tell me what is the total mass balance? You can use this envelope. What is the total mass balance?
F equals D plus B.
Yeah, good. Or so 100 equal to D plus B. This is equation number 1. Okay, for the component, anyone?
F times ZF equal to B times XF plus B times XB.
Yeah, And we know all the value, right? So xb xf the f is 0.5, yeah, from the calculation, and then this is the d, yeah, xd, right? This is 0.9 d plus 0.1 b. Okay, so now you have two equations. You have two variables, d and b, and you can solve the value of d and b. Okay, can someone can you try solve this one? So for example, d would be 100 minus b, let's say. So I can you can substitute, it's up to you. 0.9 100 minus b minus plus 0.1 b, and then you can try to solve it, yeah. This is this is 90 minus 0.9 b plus 0.1 b. So this become up to here, it will become 90 minus 50. This one goes that side, would be 0.8b. So 0.8b is equal to 40. Then b equal to 40 divided by 0. You got the same, you get similar number with me? Let's try and let me know if you have similar answer with me.
Yes, ma'am.
Okay. 50, yeah. Okay. Where is it? Okay, so this is 50 and D is 50. Okay. So calculate the bottom of product flow rate. So it is 50 kilomole per hour. Okay. The next one. Right. The next one. The next question. This one. I'll try to group. This case, I think you do need to do it by yourself, because otherwise I won't be really good with this one. Okay, please try to do number two. Of course, to solve this one, you need the graph, yeah? It's really up to you if you want to do it using your online like this, yeah, using trackpad or using tablet. It's really up to you. Okay, there. Okay, right. Within the use of XY diagram, determine the reflux minimum. Do we have all the information we need to get the reflux minimum? Yeah, maybe we can start to plot the XB, XD, and ZF. Yeah, so it's basically this is 0.5 is the ZF. And also we have, for example, this is XD there. And we have XB over here. And we can to find the reflux minimum, we need to find the I or the intercept, which is XD divided by RM plus 1. Yeah. Okay. What else? What else the information that we need to put into the graph?
Q line, ma'am.
Q line, right. Q is 0.5, so the slope is Q minus Q divided by Q minus 1, isn't it? Yeah. So I would think this is 0.5 divided minus 0.5 equal to minus 1, yeah? So minus 1 would be delta y divided by delta x, but because minus, so that would be, I would think this side, yeah? So this is the Q line. Yeah, I think that this is the Q line. So draw using your graph, using your ruler from here to here. Okay. If you want to draw in for example here in the work, it's also fine. Let's try. So then you have to see from home and then draw. Yeah. No. Home and insert, yeah, insert and shape, and then you make a line, let's say from 0.5 to here. It's really up to you, yeah. Which one is better? Which one is better to make the graph? Let's make this one. I don't have physio with me, so usually Pak Danu use a lot of physio, but I don't have physio, so I'm gonna use maybe this one. And then, okay. Oops. And then let's make a point. Maybe this is the point of distillate, the ZF, as well as the bottom, yeah. Okay, and then we need to find the intercept, so we can draw the line here to the intersection between the Q and the curve, yeah, and the equilibrium curve, in order to get the intercept. Oops, it's not really from, we need to really make it pass, should be very close to this. Yeah, and then thing. Okay. Okay, with calculation, what is the number of your intercept?
0.39 or 38.
0.38. How about others?
Yes, around that number, ma'am.
0.38. Anyone who get 0.4 or 0.35?
I got 0.4, ma'am.
There's 0.4.
Yes.
Did you use it using pencil or in the computer?
Pen.
I did it in the computer, ma'am.
And you got 0.4.
Yes.
All right. Okay. Let's submit this one as an assignment, yeah, this weekend, so we can check the variation of answer, yeah, and of your answer. I would think this is 0.38. Now, I really need to use calculator. I really need to use ruler actually to know the this one to get the scale of this, yeah. Is it 0.38 or who got 0.39? Anyone get 0.39?
I'm not sure, ma'am, but I also got similar like yours, so it's
Okay.
38 or 39.
Okay. Can the way you calculate it is did you do it using our paper or computer or laptop?
I used my computer.
Oh, okay.
I use paper.
Yeah. I didn't have a ruler with me now, but here's the things. What you can do to calculate the exact the comma there is to first you find the length between from here to here, right? And divide it from here to there. So and then you divide it. So it looks like ratio, and you're gonna get. Can we? In here, can we measure something? Yeah. So maybe let's say around. I'm gonna use one of your answers. So what is the best answer? 0.38, 0.39, 0.4.
38, I think, ma'am.
Okay, I'm gonna write 0.38. Yeah. Where is this? Okay, so let's say when you come here, you get the let's say you got here is 0.38. Can I insert a line here? I think should be, yeah. Oh yeah, I can insert line. So I think I can just delete the previous one. There. I'm just gonna use the line there. Okay, from here to here, 0. There for the Q line, and also there from from 0.9 into the okay, yeah, but this one. So I think yeah, let's say 0.0. So the intercept is 0.38. Yeah, so that means 0.38 equal to XD, which is 0.9 divided by RM plus 1. So what is RM now? Can you calculate it for me? So I'm calculating that RM plus 1 become 0.9 divided by 0.38. It becomes 2.36. So my RM now is 1.36. Is that correct?
Yes, ma'am.
Yeah, or yeah, plus minus, yeah?
7 actually.
Oh, 7, yeah. Okay, right. Now, once you know the RM, write your slope, your I, sorry, your new I, which is xd divided by r plus 1 of equal to 0.9 divided by 2.37, yeah. So that's become, oh no, not 2.37, but so you need to find RS first, and your R is this one, yeah, 1.25 multiply with the minimum reflux. So 1.25 multiply with 1.37, that would be equal to 1.37 or 1.71, and then you just have your new 2.71 would be about 0.3, yeah, about 0.33. Okay, yeah. Did you get the same answer with me?
Yes, ma'am.
Yeah, okay. And then let's try with your ruler, find the scale. Maybe I would think about these points there. And then draw the, okay. Draw the, where is it? Shape. Okay, draw the line from here through this point there. Okay, so that is your operating line. Okay, and once you know the operating line, what else is gonna be just easier? Just write find your bottom operating line or the stripping line just from the bottom there and do passing the intersection there, right? And then after that, calculate your stage number. Maybe you need to calculate your time as well. How much time do you need to make your calculation using computer or using PowerPoint or Word, for example, compared to if you do it using calculator. Okay, let's try if we still have time. So that become 1. I would like, I may want to zoom it.
Ma'am,
Yeah.
I'm sorry to cut off a little bit, but after this we have system utilitas exam, and Pak Miki told us that we will have briefing by 2:50.
Oh, okay. All right then. No worries. You can do it at home. You can try it. But tomorrow I'm gonna continue with Bu Grace as well for 1 hour, and after that, you should give us just submit assignment like hopefully in the weekend, yeah, on Sunday, and then another 1 hour I will start talking about multi-component distillation. Yeah, is that all right?
Yes, ma'am. Thank you.
Okay then. Right, I'm gonna stop the recording and then